So in this video, we're going to introduce anti-differentiation. Now, let's think about what is differentiation. Well, differentiation is if I have something like a y, an f of x, or something like that. If I would like to get the rate of change of y, or the rate of change of a function, so y dash or f dash x, well, then we derive. Now, anti-differentiation, to put it pretty simply, is the opposite of that. So if I want to go from the rate of change back to the original function, or that is when we have anti-differentiation, or the antiderivative. So if we had to write this as a sentence, anti-differentiation equals opposite of differentiation. It's the inverse. It's the reverse process. So let's look at two examples and see how it works. Well, let's think about a derive example. So let's derive y equals 3x squared plus 4x to the 5. Okay, a nice simple example. So if I want to derive that, I multiply by my power, reduce my power by 1. Multiply by my power, reduce my power by 1. Now in both of these cases, our steps were multiply by power, 2, reduce power by 1. Now, if we want to do the opposite of that, so that's how we derive. If we want to do the anti-derive, well, you bet that these steps are reversed for an antiderivative. So we're going to write that. Steps reversed for an antiderivative. Okay. So just scroll over a little bit. Now, the way we write antiderivative is also a little bit different, and we're actually going to start with this exact same equation, because we're going to show you how we can go back to the original equation. So we are going to anti-derive / anti-differentiate, differentiate y dash equals 6x plus 20x to the 4. Now, the key thing is we need to use the correct notation. So what I mean by correct notation, when we do derivatives, we know that derivative means d dx, the derivative of our function with respect to x. If we want to look at the anti-differentiation, it is the integral of something with respect to x, or with respect to whatever variable we've got. So the integral of 6x plus 20x to the 4 dx. Now you'll notice that I accidentally said the word integral. It's because antiderivatives and integration are so heavily intertwined. And this symbol here that we just wrote is the integration symbol. Okay, so don't worry about what that word means for now. Just know that that's the symbol that we're using. So let's think about this process in reverse. As we said here, an antiderivative is just the reverse steps. So instead of multiply my power by 1, instead of multiply by my power and reduce my power by 1, I'm going to do the opposite for all of these pieces. So my new function, let's have a look. I'm going to increase power by 1. So I'm going to go to 6x to the 2. Then I'm going to divide by my power. Divide by 2. For the next one, I'm going to increase my power by 1, 20x to the 5. Then I'm going to divide by my power, 5. Now, I can simplify these little pieces to get 3x squared plus 4x to the 5. And as you'll see, this original function is what we have resulted in. Now there is a difference though, is whenever we do an antiderivative, we have to put something on the end which is just says that there could be any constant on the end because we don't have any more information. So at any antiderivative we have to put a plus c because we don't know whether there was a number hanging off the end of the original function. What do I mean by that? Well, if we look back at our original one that we derived, if I had a plus 60 on the end of it, well, I'm going to get the same derivative, right? I'm still going to get the same derivative here if it had a plus 60 on the end of it. Okay, it could have had a plus 100 on the end of it. I'm still going to get that same derivative. So all we're saying by putting a plus c on the end of it is, hey, without any more information, we don't actually know whether there was like a little plus 100 on the end. We just don't know. Okay, we'll go deeper into how to work out what that c is in a little bit, but not right now. Okay, we just need to practice these antiderivative skills. So as you saw, the opposite skills, we're going to increase power by 1, and then 2, we're going to divide by new power. All right, so I think we need to get into some examples now.